Like many of you in high school, I was a very high achieving honor student. I did calculus in 11th grade, did multivariable calculus in 12th grade. I had the highest grades in the class, most of my classes, the highest SAT scores, PSAT scores, all that. And while that's good to a certain extent, I was actually robbed of intelligence that I could have had. Not by anybody externally, but because I myself hadn't really gotten to the level of challenge that could really build intelligence. In college, I studied a bunch of things, but eventually decided to study mathematics. And that was where I was actually put in a circumstance where I could actually get smarter. I don't just mean learn more stuff. I don't mean just learn a couple more formulas or facts or whatever, all that kind of high school stuff, but actually build my brain, actually get smarter the same way that with weightlifting or running, you can make your body physically stronger. In college math, I really felt that was happening. The biggest difference was that in high school math, you'd basically know how to do a problem, and then you would just apply it. You'd learn a method and then use the method. They would tell you what to do, and then you would do it. And they might be the textbook, or it might be the teacher, or whoever. But in college math, a single problem, we would often struggle with one problem for 10, 15, 20, 30, 40 hours for a single problem. Sometimes we would struggle for hours and not even get it. And this would be the, 10 or 15 best math students in the school. I mean, it wasn't that we didn't know what we were doing. It's just that the stuff was so hard. And in that process of struggling with individual questions for a very long time, I was able to really get a lot smarter, like in just a physical, visceral way. When I took the SAT in high school, I had, my combined super score, whatever, was a 1580 out of 1600. It was the highest grade, and it was the highest score in my school that year. But I finished it basically in the amount of time allotted. I had to guess on some problems, just stuff that you guys have probably experienced. But when I took the GRE and GMAT, and that was after college, after this level of training where I was actually getting so much intelligence building was happening when I was taking the GRE and GMAT, which are harder tests, by the way. They're much harder than the SAT. I had perfect scores on both of them. There was no question in my mind. I knew that I'd gotten those questions right. I wasn't guessing or, hoping or anything like that. I knew it. I was finished. I finished the GMAT an hour and 20 minutes early. I finished the GRE about an hour and 45 minutes early. And these are both 4-hour tests. It's a completely different experience. And what allowed that to happen was going through this process of struggle. See, when you're in high school or middle school or whatever, and you're real smart, you're used to seeing yourself a certain way. And you're used to seeing yourself as a person who doesn't need to struggle. And so when you do struggle, it can be really uncomfortable. It makes you feel like either the problem's wrong or you're wrong or whatever, because you know that you're the type of person where a problem should only take you 30 seconds to do. That's certainly how I saw myself. And when I was now faced with these problems that I had to spend, 10, 15 hours on and sometimes not even get them, it was very strange. It was a very strange experience, but an incredibly valuable experience. There's a saying that I heard as a kid, and it just really stuck with me. And the saying is, A students work for B students who work for C students. And, having had many students over the years and having seen a lot of these struggles, it makes sense why. Because B students and C students, they have to struggle. They fail. They have to rise up. They need to be resilient. A students don't ever have to do that. A students in high school are just people who are really good at following instructions. That's the only skill they really have. If you think about it carefully, if you're an A student getting A's on everything, the thing you're really good at, and when it comes down to it, is probably mostly following instructions better than other people can. It's a fantastic skill. I'm not saying it's a bad skill, but it doesn't build resilience, doesn't build perseverance, and it doesn't give you that ability to figure out new things that other people haven't figured out. That's why so many, entrepreneurial innovations or whatever, they don't come from A students, because they're coming from people who aren't great at following instructions, but are great at surviving and being resilient and figuring things out. So in our curriculum, in the VORA method curriculum, I really try to capture that. I try to make sure that you guys are able to experience that actual intelligence development where you're struggling with a problem for a long time. Now, it's easy to get in your head. It's easy to get in your ego on this and saying like, oh, this is taking me too long. I don't want to do it. Oh, this is taking me too long. It means the problem's stupid. Oh, it's taking me too long. Maybe I'm stupid. You got to get rid of all that. Anything worthwhile is supposed to take a long time. It's supposed to require a lot of trial and error, a lot of struggle. If you don't believe me, you can ask any entrepreneur ever. You can ask any great writer ever, any great artist ever. You can ask any great computer programmer. They're all going to tell you the same thing, that what they do is overcome obstacles, and it often takes a really long time to overcome those obstacles. And it doesn't mean that they're bad at things. The proof of Fermat's last theorem took one mathematician over 30 years. And this is a world-class mathematician. But he was building on hundreds of years of other people who weren't able to do that proof. The Fermat's last theorem, by the way, it's a simple looking theorem. It's just saying that if you have the Pythagorean theorem, a squared plus b squared equals c squared, you can find some integers that work. Fermat's last theorem says that if it's to the third or to the fourth or to the fifth, it's not going to work in the same way. That's a simple theorem, and it took so long to explain. A lot of our problems are designed the same way, that the actual problem's going to look simple, and sometimes the solutions even be kind of elegantly simple. They're supposed to be like that, and it's supposed to take you a long time to figure them out. Now, most people who are B, C, or D students who come to Format, they don't find that different because they're used to struggling. A students, sometimes it's harder for us because we're just not used to it. Now, this next series of problems here, a lot of them are going to be, not all of them, but a lot of them are going to be like that, where it's going to take you a while. That's how you're going to build that kind of intelligence. It's how you're going to get to a level far past where you are if you're just going through that following instruction type mode. So consider this a bit of me sharing some of my experiences. I hope you find them useful. And I think that these next series of problems, you're going to find the ones that you're going to find useful are going to be the ones that you struggle with.